get this for. Okay, all right. So we are going to. Okay, all right. Thank you, everybody, for being here today. I do apologize for how, if you're not able to really see or hear very well. We're going to try to, in the future, get bit longer cords and things like that so we can kind of do more with the screen and all that good stuff. Welcome everybody that's here in person and here on Zoom. This is going to be a presentation on DNA and genealogy presented by Linda Colston, who works quite a bit with DNA and genealogy, and she was also a former staff member here at the Kentucky Historical Society. And I think without further ado, I'm going to hand that on over to her. So thank you.
Hi, everybody. I'm also a DAR member too, Frankfurt chapter. They talked me into First Vice Regent. You heard that now, but maybe not later. Just kidding. Welcome, and I hope you all are here for the DNA to kind of learn more about it. Now, DNA and genealogy. How many of you know that they go hand in hand? Few of you. They do. Got to have them hand in hand. Can I talk louder? I doubt it. Yeah. Okay. You have the traditional tree. Is that better? A little bit better, not much better. Do you want to move on up closer? Okay. You have your traditional genealogical tree and you have your genetic tree. Now, they're two different trees, or a lot of us like to combine them into one. Your traditional genealogical tree is the tree that has all your documentation, okay? All those paper trails that you go looking for those cousins, the pictures and all that fun stuff. Your genetic tree is the one that involves the DNA. It is telling you which cousins you match with. It is not going to be as full as your traditional tree unless you add the matches to it, okay? Because you're not going to be receiving DNA from every single cousin you have. It's only just what is passed down through the process. So whether you're doing 2 trees or 1, I take the traditional tree and I just add the genetic tree to it when I make the connection. The traditional tree research is needed before, during, and after utilizing DNA. Not just one time, you've got to do it throughout the process. Genetic trees can fill in the blanks. They can verify the genealogical trail, solve brick walls, and find relatives, and sometimes research partners that can help you with it. The bushier the tree, the easier it will be to work with the matches. Sorry. And what I mean by bushier tree is you want to take those cousins down. You don't want to take just the lineage back like we do for DAR, just that straight lineage. You want to bring it out. You want to look at those cousins, those siblings. You want to bring those down because those are going to be the descendants of those people are going to be your matches. Okay? Well-documented trees are a must. Why? Do you strive for more than one source to establish facts? Does the evidence address any inconsistencies? Are you following the GPS, genealogical proof standard? Why is this important? Because DNA is going to help verify the facts already established and help clear up inconsistencies. Have you gone back at least 5 generations? Now, there may be blanks. You may have a great-grandparent couple that you can't find, but have you taken those back that you can find? Why? Because the more people you have identified in your tree, the easier it will be to recognize and place the matches in your tree, okay? You're going to save yourself time in the long run if you do this at the beginning. Are you prepared to work your tree forwards, backwards, in identifying connections? Are you prepared to work other trees and even create other trees? Why? because you're going to be building lots and lots of trees. If you get into setting the matches, you're going to build a lot of trees.
Ma'am,
Yes, sir.
can we ask questions as we go along? Or could we just- oh,
If you can hold them, that might be good because I might lose my train of thought
okay.
and then we'll spend double time trying to get back to it. But keep track of it. All right, come on. There we go. All right, talking about DNA. There are 3 basic tests that we focus on now. Autosomal DNA, which is basically, it goes up to 6 or 7 generations and incorporates both the male and the female line. Y-DNA looks at the male line and goes to the fathers, 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 or the son, 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 just the male direct line. mtDNA is the female line of the mothers, 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 mothers. So those lines are a little bit more limited, but they are also very useful, and you want to incorporate them when necessary. Now, there are different companies that have them: Ancestry, MyHeritage, 23andMe, Living DNA, and there are others. But Family Tree DNA right now is the only one that is really doing mtDNA and Y-DNA. Here we go. And here's more of a visual. The blue that you see on here is my father's 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 father going on up. Okay, and then you can also bring that forward. Family Tree DNA has done a lot with the Y-DNA over the last couple of years. They have increased it from just 37 markers, 64 markers, 111 markers, or 67, 111 markers. They now do the whole genome, the big Y. That is something really to look into because that is specifically identifying the haplogroups, and it's taking it really far back, but is also bringing it forward a bit to where you can sometimes pinpoint locations to find the matches you're looking for. Now, the purple on this screen, pink or purple, is for the mtDNA. You have got the mothers, 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 mothers. And as you'll notice, you're going to have different surnames: Rogotsky, Kapitsky, Stieber. You've got different names to follow those. That is probably the one least worked with so far. However, Family Tree DNA is starting to focus on mtDNA the same way they were doing the Y-DNA, which means stay tuned. There's going to be more to come that you can utilize with the mtDNA. Just a reminder about autosomal DNA, because that's what we're going to focus on today, is the randomness of inheritance. The big soup bowl in the middle are your parents. You have one child on the right who gets a ladle out of that. They're going to mix it with the significant other parent, and they're going to ladle all that out. What comes out of those bowls is random, okay? Totally random. Big pieces, large pieces, may not have any pieces at all, may have nothing but carrots in it. It's all random. And that's what we've got to remember. Now, one exception, there's always exceptions to everything. Unlike the vegetable soup, when you're going to run out of peas and you take the peas out of the vegetable soup and put it in a bowl, and that's less peas in the bowl, DNA doesn't work that way. It's just like they never took it out. It's like Hermione Granger's purse, if you ever watched Harry Potter. It's just bottomless. So you can receive the same pieces of DNA or different pieces of DNA. I'll get the knack of this turning. DNA is measured, for autosomal DNA, is basically measured in segments, and that's just the pieces of DNA. When you inherit a match and you see 134 centimorgans, that's not just one piece of DNA. That's bits and pieces of DNA, different sizes. DNA is measured in centimorgans, okay, CMs. Now, some companies use percentages, and you can easily convert the two. So you can see on this map, the first picture you see up there, I wish I had my pointer available. You see the chromosomes that we have. And when you inherit from a parent, you notice that there's 2 of them. Now on here, they're kind of pink and blue to kind of separate them. That's for the maternal side and the paternal side. Now, the thing to remember is if you go to put these on the chromosomes to see where your matches are, you don't know which one, if the top one is paternal or maternal, until you figure out the matches that you've put on there, okay? The second one over is showing different matches and they're pieces of DNA. You see long pieces, you see short pieces. Those are where your match and you share DNA on different chromosomes and different spots. Okay, and the bottom's just kind of a larger picture where you can see some of the overlap, where they start and where they stop. Now, there's two ways that we traditionally are working with the matches and stuff, or the DNA. One is shared matches, which is the first one where we're taking the matches, and it's probably the easiest one to really get started working with. Okay, get familiar with that, and the other will come a little bit easier. And the second one is chromosome analysis. Now, one of the differences between the two is that shared matches is indirect evidence. Okay, that means you have to have other evidence to support it. You cannot necessarily hold it alone by itself in regards to the names of the people, the identities, and we're going to see why in a little bit. Chromosome analysis is direct evidence because you're actually taking that little piece that you match and you're overlaying it onto your chromosome map to see where they fit. Okay? So with shared matches, it's indirect evidence. It's the total number of CMs, the number of segments, and the longest segment is what you're going to be focusing on. Okay? I'm sorry, I keep saying okay. Estimated relationships. How are you related to people that way? The opportunity to build lots and lots of trees. I'm going to repeat this over and over again because you got to be prepared for that. You're going to get these trees, not just yours, others. You got tools from these companies. Utilize the tools, especially the notes, because chances are you're not going to spend and solve it in an hour. And you might set it aside, get involved. You got to take the dog for a walk, come back, and you want to remember where you stopped and stopped it so you can start back. And of course, potential for research cousins. Chromosome mapping is direct evidence. MyHeritage, DNA Painter, and GEDmatch can do it. MyHeritage and them will do it for you. DNA Painter, you do it yourself. And that can be seen on dnapainter.com. So you want to get familiar with that site because that's got a lot of good tools with it. This gives you the visual of where the segments fall. You can see what piece you share with your cousin Tom. You can actually see that on the chromosome map. The size of the segment is given with starting and stopping points. Now they're going to be a little fuzzy, but in general, they're going to be okay. And I say a little fuzzy because each company measures things a little bit different with their algorithms. This can be time consuming. It takes time to get these on there, even though they've got tools that will transfer them to it. It takes time to sort through them and figure out what's going on. And matches segments may link to more than one ancestor. That's what they have recently discovered, is that just because you shared this segment and this segment with Sally doesn't mean that you share the same ancestor with this other segment with Sal. That may go back to a different ancestor. So it takes a lot of work to try to figure these out. And so there's constantly being improvements. And that's why you want to utilize the sites and stay on top of it. Here's the DNA Painter, the shared centimorgan project. This is a version that is open to everybody. It's not necessarily just company limited. And then I always use it as the backup. I use it to help me confirm what I'm thinking. When you use it, you want to use the beta version because it is the most recent version because they're constantly adding statistics to it. And you can see on here, you put in the centimorgans, and this is the chart of all the potential relationships that you may have with somebody. Notice there's a lot to try to sort through. And it's very important to remember that DNA does not name names. Now, this comes into play when you're looking at who was my great-grandfather. Well, you can find the great-great-grandparents with it, but if there's 3 or 4 sons, it's not going to tell you which son it is. That's when traditional genealogy comes into play. You've got to find the resources, the records and stuff that will help you put the right person in the right place at the right time. So you're lucky if Peter went off to college and was gone for 4 years, then you could probably John. But if they're both in the same area, same time, and either one of them could have done it, it's a little harder to figure out. Okay. So we're working with matches. When you're starting out, I mean, matches, the more you identify, the easier it is to identify more matches. Because once they're identified, you've already got the side of the family they're on, you can look at other matches. But you want to start out with the known matches. Go ahead and whatever program you're using, or if you're doing it on your own records, work from the highest centimorgans down. And this is going to give you practice recognizing relationship potentials and utilizing the centimorgans and identifying. If it's your third cousin, you know it's your third cousin, identify it. Because when it comes to shared matches, you're going to be able to find and know what side of the family that match may be on. For unknown matches, start with those who have a tree. Get practice working their tree as well as yours. You're comparing two trees, you want to make sure that you've got all the information necessary. Okay, remember GPS, you want to exhaustive research, you want to have all the information necessary. At this point, the key is finding the connections, okay? For those without trees or very small trees, maybe go on down to the next one, because that's going to take a little more work. And if you identify what you can, that may help you identify these matches as you work your way down. Shared matches become more relevant. These are the ones that you are in common with, that they share DNA. If you ID these at these steps, which we'll see later, then you will know, like if they're on a paternal or maternal side, and you may even know which grandparent couple you share with. Okay, so identifying what you can is going to help you down the road. Now, understanding relationships. Aren't those fun? Y'all have heard of half cousins, you know, removed cousins, all of those things. Well, we got to understand what those are because they play a role. Full cousins, full relationships share the same grandparent couple, or what we call the MRCA, most recent ancestral couple. Okay, those are ones where you come down, your first cousin, you share both the grandma and grandpa. Okay, those are your full cousins. Half relationships are where you only share with one of the grandparent couple. And in this example, you've got Effie, Joe, and Lillian. Joe was married to Effie first. They had two children, Bessie and Lorraine. Bessie and Lorraine are full siblings. Okay, their descendants will be full siblings to each other. They connect. Joe and Lillian had Lonnie, Larry, and Sandra. They're full siblings to each other. But Lorraine and Bessie are half siblings to Lonnie, Larry, and Sandra. Does that make sense? Because their only connection is through Joe. Okay, so this can help if you've got a child that was born right in between a marriage of two people. If you get DNA from both those lines down, you can rule out which one is not the mother. Okay? Typically, and this is examples of what you see on DNA Painter, but typically, if it has half the centimorgans you expect it to have, then it may be a half cousin. Okay, so if you look at these, a second cousin on average shares around 229 centimorgans, but there is a range of people showing up as second cousins from 41 to 592. That's a big range, isn't it? So you want to look at what's closest to the average. For the half cousin, it's about half of that, about 120. Still falls within 10 to 325, but if you can tell, it's about half of what the full cousin would be. So that's something you want to keep in mind, okay? Sometimes a half cousin is a whole lot easier to work with because you can rule out that one side, especially if it's an unknown. So that's something to keep in mind. We did it. Removed cousins. Does everybody understand removed cousins? It took me a while. It took me a long while to do that. But before we get to the removed cousins, we have to look at birth years. That's what we consider when we're looking at removed cousins. If you and your match were born around the same time frame, 1953 to 1960, then you're going to be in the same birth year because generally speaking, a generation is about 20 to 30 years. MyHeritage does it at 25 years. But when you're looking at from one generation to the next, you want to give a 20 to 30 year span on that. So you can see the birth years on the chart here, where you have got down at the blue section, 1953, 1960, they're on the same line. Okay? That means they're going to be the same cousins. If the 1980, you're looking at that in 1960, you're looking at a generation below. Okay, that's separated by a generation. That's what we call once removed. And the same thing if you work up. So you can see 60 to 80 is going to be once removed, just one generation removed. If you use 1960 to 1906, 2 generations, twice removed. Okay, is that making any sense? That's why you want to put them kind of in line with each other. Now, there are exceptions. If you have people with many children, my husband and I are an exception. He was one of 8 kids, the second to the youngest. His oldest siblings could be my parents. They're the same age as my parents. So that kind of is skewed with us, but that's something to keep in mind too. If there's a lot of kids involved where they overlap or late in life, children and stuff, it could be different. But generally speaking, when you pair them up with the match, if they're above or below, they're going to be removed. So what are potential relationships? These are the relationships that when you put in the centimorgan number, you are going to get something like one of these, depending on what program you use. DNA Painter is the one under the title there. And what they're showing is that there's a 50% chance you're going to be second cousin once removed, half second cousin, first cousin 3 times removed, half first cousin 2 times removed. Handy, isn't it? What's the problem? Which one of these fit? That's when we got to do some more work on this, okay? And when you compare them to DNA Painter, for example, you will see that things may be a little bit different. They may put them in a little bit different percentages. But generally speaking, the easier way to do it is to start with what you can at the top, and we can narrow that down a bit, and then work your way down. It can be down to 1%. It is possible you and that match are a third cousin, once removed, sharing 134 centimorgans. That is possible. But statistically, it's not as possible as 50%. That's where the genealogical trail comes in. That's where you want to do the paper trail. Where does this cousin fit? And then you want to compare the genealogy with the genetics to see what's more on the right track. Can y'all still hear me back there? Okay, I'm trying. So, but in addition to traditional genealogy, there's other factors to consider from the DNA perspective. You also want to consider ethnicity estimates. Now, that was something that kind of surprised me. I'm going, well, how do ethnicity estimates play a role? They play a role. Time and location. Now, that's a key genealogical term, isn't it? We want the time and the location. Shared matches, our network of people we want to work with. Anybody ever heard of pedigree collapse, endogamy, multiple relationships? Yeah, that comes into play too. And if you can recognize that, you're on a better footing. Targeted testing. That's where you decide, who do I need to test for this? So let's look at these a little closer. Ethnicity. When you have a match, you want to compare the ethnicity estimates. Because if you look at this one, and I've been using Heidi throughout this, so we're looking at her numbers and stuff. Heidi and I are very comparable in where our ancestors came from. Now, she has a little more Germanic Europe, whereas mine is Eastern Europe. But when you get all said and done, they're still kind of German people, right? We've got 37%, 38% England, Northwestern Europe. Okay, so if we look at Heidi's tree, she's got, if you look back up at the grandparent, great-grandparent level, she's got Wales, Pennsylvania, Danzig, Germany, Pennsylvania, England. I put their born and then passed away in those 2 locations. And then you look at the maternal side, and we have got pretty much West Virginia and Virginia all the way down. So we know where the England and Northwestern Europe side is, don't we? On the maternal side. When we're looking at the paternal side, we've got couple possibilities. If we overlap on the German side, I've got that grandparent couple to look at, and I've got a question marks. Her tree's not quite as full as it should be, is it? But we can't ignore that, okay? Because our ancestors could be right there among those trees. Time and location. Who was in the right place at the right time? Is your ancestor, if her ancestor was born in Wales and ended up in Pennsylvania, and yours was in Virginia and ended up in Illinois, is this likely to be your ancestor? Maybe, maybe not. You've got to look at the genealogical trail. Okay, so consider those, especially if you're feeling puzzled. And the smaller the ethnicity estimates, the chances it's further back. Okay? So those German lines and stuff were a little further back. Pedigree collapse, endogamy, multiple relationships, PEM, as I call them, because they're all kind of similar, but they all cause some of the same problems. Pedigree collapse is where you've got lines that go back to the same couple or ancestor. On this one, you can see, I've told people for years I'm related to Joseph and Mary. And the truth is, I'm related to them in 3 ways. I got 3 lines that go back up to Joseph and Mary. Now, this is the Spencers that came from Lee County, Virginia, but it's the same pedigree collapse. And actually, everybody ends up with pedigree collapse at some point. It's just that those that are closer to us impact the centimorgans more. Okay, so you may have inflated some, but that's because you're going back to the same couple. The positive side is that you have less grandparent couples to consider. So you rule out a couple of those. Endogamy. You've heard of endogamy a lot of times. That's probably the first one I think that kind of came out. And that's basically with the same ethnic culture, social, religious, or tribal group kind of came together, intermarried, stayed with each other. Appalachia falls under that, or Appalachia. I'm not sure which is the right pronunciation, even being up there living for a while. It's considered young compared to like the Jews or the Amish or the Acadians, etc. But it is still where you have got multiple skewed centimorgans being passed down. Multiple relationships, and they're skewed and they can be inflated, which means you may be related to somebody in more than one way. Just looking at this, you've got a Spencer marrying a Watkins, the same family got a Spencer marrying a Watkins again, and you've got Chapman and a Spencer and a Spencer and a Spencer and a Moore and a Lucas and a Bowman and a Lucas and Moore and a Lucas. You've got all these people intermarrying, and they may be second cousins, or they may be a first cousin once removed. If you see higher than the average for those, what you think the relationship is, it might be that you are related to that person in more than one way. So that's something else to consider. Now, the good news about the PEM is that their impact decreases over time. So the further back you go, the less impact that's going to have on you. And eventually your centimorgans will even out to what they should be. So you want to consider if they're more than one relation, you want the bushy trees to help with that so that you can link to those that in all the ways that you link to them. If you're missing a line because you didn't want to research that brother, you might be missing a double relationship there. That because that brother or son could be related to you in a different way. Ancestry has a tool. Their tool is called timber. Timber is really helpful in many ways. If you look at this example, the shared centimorgans of 130 is across 6 segments. Unweighted DNA centimorgans is 130. The longest segment is 58. Because the shared and the unweighted are both 130, that's letting you know that there is less chance of PEM coming into play. Now, ancestry applies it to anything 90 centimorgans and below. So we look at the next example, 71 centimorgans across 4 segments of shared. Unweighted is 84 centimorgans. Okay, it's telling you that there's likely PEM going on. Now, It's not going to necessarily tell you who or where, but it's letting you know that you need to be aware of this. Okay? To help with this, you want to consider the longest segments. That's where these come into play. The longer the segment, the stronger the match is with you and the match, okay? With what you share. When you get into these little tiny segments that are less than 20, you have got to consider IBD and IBS. IBD is identical by descent, and that means pretty much everybody in the same general area, Appalachia, are going to inherit some DNA pieces that are similar, just as they would in other areas as well. That means that it's not necessarily you relating to that match, it's just DNA that you guys share. Identical, wait a minute, did I say that right? That's identical by state. Identical by descent is what you actually share through the descendant. That is actual cousin. So when people talk about the small centimorgans and matching them up, they're trying to pull out the IBDs to match with the ancestor. Okay, shared matches. This is your network, okay? These are what's going to help you down the road when you find who you likely share DNA with. Now, these are not necessarily 100% accurate. You may end up with some people on the shared match list that doesn't match any of them. That could happen, or matches somebody in a different, unique way. But these come into play because it can help you find the maternal side. It can help you identify the cousins. When I put Heidi in here, this is what comes up. Now, my paternal side was the English side, England, that part. My maternal side was primarily the West Prussia, Eastern Europe side, okay? So that's telling me that Heidi's not related on my West Virginia side. We're not likely related there. We're more likely related on my maternal side because all these other matches that I've been identified are on the maternal side. So you want to work these as you go, make notes. I like to also say second cousin down from so-and-so to Teresa, you know, more details so I can better understand which one it came from. Because sometimes you're going to find matches that were siblings and stuff, and you can just place them right there in the tree without even doing too much more research. Targeted testing. This is if there's someone you can't find who you're looking for and you want to do targeted testing. You take over here on the right side, shows you, and I think I skipped over that slide, but basically you start down at the bottom with you, with your parents, you share siblings. With your grandparents, it's first cousins. 2 times grandparents are third cousins. Fourth cousins are 3 times great grandparents. You notice how that goes up. If you're wanting to find that blank chart there under Ken and Marie, and you're looking at David and Michelle, no, let's forget that example. Look under John and Sarah. Say you're wanting to find Dennis's connection to it. You have got Mark, Dwayne, and Dennis that are siblings. You don't want to target test them because you already know how you're related to them, and they're going to take you up to Carl and Pearl. Okay. So you've got Katie there who goes up to Peter and Lillian, and then you've got Margaret who goes up to Tom and Kay at the very top. One of those cousins, somebody in that family might be a good target test to help you find John and Sarah, if you couldn't find those. Hopefully that's making a little bit of sense. But it's basically following the tree down to where you've got the blank and then going back up and saying, what kind of cousins can help me? And you don't want cousins that where you share that same grandparent couple with. You want them, the siblings of that share that coupling. Okay. So for a first cut, you want to look at a second cousin. If you're looking for great grandparents, you want to look for second cousins. For third great grandparents, you want to look at fourth cousins. Okay. Now, typically, and I think that slide slipped by, autosomal DNA is great for 3 generations and closer. You start losing the DNA, it starts decreasing the further you go back. And I think I got another slide that shows the same thing, and I'll cover that then. So let's take a look at Heidi. Picked Heidi, and partly because I picked her because it's an estimated second to third cousin. So we can start there. She has a public tree, which is helpful, 572 people as opposed to the 1 or 2 privates that you often see. We share 130 centimorgans across 6 segments. It's unweighted, so doesn't look like endogamy is going to be a big part of that. And the longest segment is 56 centimorgans. Now here's the chart I think I missed earlier. When you're looking at autosomal DNA, we're looking for the most recent ancestral couple, but you want to start with this kind of concept in your mind. When you start with yourself and you go back each generation, you start with your siblings. You've got 2 parents. You get 50% from each parent. You go up to the grandparents. They're your first cousins. You've got 4 of them to look at, and there's a 25% chance of inheriting DNA from them. And you're likely going to inherit from second cousins and third cousins. But when you start looking at 5th cousins, that's 4 times great-grandparents, 64 people to trace down forward. That's not many, is it? Not many at all. No. 64 people for a 1.5% chance of making a connection. Now, the good news is you've got that 1.56, but it's going to take a lot of work, isn't it? Eventually, you've already, by the time you hit the 6th cousin, 5 times great-grandparents, you're down to less than 1%. Okay? And a lot of people who get upset because they say they've got Native American blood, DNA, they just know they do. Everybody says they do. Well, first off, we know that's not necessarily true. There's a lot of things to consider, but one of the factors that can be considered is the fact that it just falls off. They're back further than the 5th great-grandparents. They're back more than 7 generations. So it's just not enough to even necessarily pass down. Some may get it passed down. If you've got a strong piece, it may be passed down, but it does tend to fall off. So looking at Heidi, it's a second to third cousin, okay? So the grandparent, most recent ancestral couple, common ancestral couple, we're going to look for and focus on to begin with is a 2 times great-grandparent and the great-grandparents, okay? Because if she falls into that second or third cousin range, those are the ones that we are going to share. So that only gives us about 16 couples to look at, right? Hopefully we can narrow it down further than that. So we want to look at where might we connect? Well, we know it's second to third cousin. And this little chart here comes in handy because we're going back to the birth years of you and the match. And when you plug in this chart, you want to put your birth date in, which is 1960, okay? You start there. You start with the oldest match. And you put their birth date in, then you put all the way back, and then you put your match's birth date in and work it up back. So with Heidi, she was born around 1980. Now again, remember the generations, 25 years, 20 to 30 years. You can take 1953 and just subtract that and get a range. It doesn't have to be exact, it can be the range, but that's going to put her in the generation. And in that very first column of circles, you're going to start with you as the blank circle. The next one you don't count because that's your first cousins, okay? Then you go up to 1 cousin, 2 cousin, 3 cousin. Okay, that's kind of the formula you use for it. So we start with 1960, and then we can move up to determine what cousin level we actually fall into. Now this one, we're looking at second to third cousin, so we didn't necessarily identify that yet. But that's kind of how you work that little chart there. And that gives you the 2 times, 1 time great-grandparent. Now, when it comes to something above or below it, as in the matches place, Heidi's spot, she's once removed. So we already know that, okay? We figured that out before. So she falls into the once removed category. We want to remember that. But we don't know if it's full cousin or half cousin yet either. So we go in here to the chart that comes up with Heidi. And then here we can look at the various cousins. And what we want to focus on are the once removed. Whoops. You want to focus on the once removed cousins. Okay, well, next one will get that one. But I also go into DNA Painter as well, and I get their perspective on that list. And you can see that you have a second cousin once removed on the 50% range. You've got a half first cousin once removed on a 33% range. So you've got, what else? Okay, we skipped that one too much. But say we were looking at a third cousin or a full cousin, you've got a 73 average. You've got a range of 0 to 234. If you click on that little box on DNA Painter, on that third cousin box, it's going to bring up, after you put in 134 centimorgans, it's going to bring up this little graph here. And this is going to give you an idea too of, okay, I'm going to look at third cousin because genealogically, it looks like a third cousin. It shows you that 130 centimorgans falls where the red arrow is. Look how far it is from the highest average on that. Look at the same thing for the second cousin once removed. What if it's once removed? You got 122. That falls a little higher up on the graph, doesn't it? So that's a little more likely than the other. Not to say the other's impossible, because that's not the case. It could be. But you want to start focusing with what is generally there before you start getting yourself into the headaches. So when we look at this, we're looking at second grandparents, great grandparents. The match, we follow the chart up. We're in that match range for second to third cousins. That's what we're utilizing. And if you see that second cousin brings up the great grandparents, you look over here at these possible relationships, and I've identified the half cousins once removed and the full cousins once removed. We know that it should be one of those if it's once removed, okay? Those are the ones that you really want to focus on. That's where you want to follow the genealogical trail to find out which one of these apply. And typically you start with the first couple tiers because that's easier, you know, if you want to fall in average. That's sometimes you don't want to be out of average. Makes it harder. So then you want to find the connection. What grandparents do we share? Are there any surnames that ring a bell? You know, that's one of the places to look. If she's got a tree, that really helps a lot. What surnames do we have in common? Unfortunately, our surnames that we would have in common probably fall right under those question marks because I don't see any. Unless it's a German name that, of course, has changed multiple spellings. That could be an issue too. So if there is not enough information available at this point, then you're going back to traditional trees. Are there blanks to fill in either tree? Which lines need to be brought forward? Do I need to start a tree from scratch? It's not always fun, is it? Or what other documentation is there? I mean, there's a whole presentation that can be done just on this part alone. What we're looking for is the most recent ancestral couple we share. In my tree, have I identified the grandparent couples being considered? If not, I need to do work. Mine are okay at this point, at this level. What about the matches tree? Is it developed enough to make a comparison? Does it need work? Yeah, we got that big question mark area, don't we? We need to work on that. And don't forget when you're looking at the relationships that it could be half or full. And so if I identified that ancestral couple in the red box as the most recent one we share in common, the next step, is that we are going to pull up that couple that we share. We're going to identify as many of the children as we can. My line's down from Daniel, John, Mary Jane, Jeff, on down. I know she's going to be a step below, but you start taking those siblings and you start working them forward. And we've worked her tree back to fill in those question marks as much as we could. Now that we've got a couple, then we want to bring it forward. Okay. And you want to bring it forward to the point where you can find a connection. So on this one, under John, we found a connection. And we can put her down there. That's where we think she belongs. Okay? Based on the siblings. So when you think you found the connection, you still want to double check with the genealogy and genetics. Is this actually a once removed person I'm looking at? Is this who I think it's going to be? Does it match with the DNA? Does everything go together? Will the tree merge correctly without odd blanks? Now, if you are still unable to find a connection, there are still options. Have you identified all of the children? That's something to consider. There may be a child there that was kind of, you know, abandoned or raised elsewhere or just didn't make it many records found. Something to consider. Would targeted testing help? You know, do I need to find some more descendants of that couple? Do I have enough matches to really consider that I have enough cousins to look at for different ones? They might bring up different things. Perhaps Y-DNA or mtDNA. If I was questioning the maternal line, I could maybe rule out a mother or two on that. What about shared matching? Can I work the network and identify more clues? Can I find some other matches that are going to lead me to the right one? And sometimes you fall on it accidentally. It's like, oh, look, this is where she fits. Heidi fits over here. And you start doing the trail back and making sure that everything is documented. If it gets too frustrating, just set it aside, go back to it later, because you're not going to solve these all in one day. And when you're, couple of other things, don't forget the GPS, missing documentation that you saved for later. Because what you want to do when you start those early trees, sometimes you have a tree with very little information. Some of you seen a tree with private, the son or child of private and private, the grandchild of private, private, and private, because they're all still alive. That's when it gets a little more disconcerting, but there are ways to find them. Sometimes you can Google them. Sometimes you can look at their profile. If you can get at least the age, birth years of their parents, then you can guesstimate. You may not have a name yet. I've got several that I don't have their name yet, but I've got the line where they fall because I can narrow it down to those people. Put that in your notes. And then that way you've got something to work with later on. Okay. And most importantly, have fun. That's the thing. If everything checks out, attach the match to your tree, do a happy dance, then get ready for the next one. Okay, because it doesn't stop there. I don't know how many matches you all have. A couple of other things. If you don't have very many matches for somebody, you might want to check to see if they were from across the water, from a country that, Germany hasn't done very much testing. You might not see very many matches from Germany. That's a clue right there that, okay, this is why I'm not seeing many matches on this person. Not because I don't relate to them, just because they're more recent across the water and they've not tested for DNA. So different things to look at. Here's some resources. Good news about PEM is that there is a new website out, a new tool called Banyan. And Banyan has been created to help work with these endogamy, pedigree collapse, multiple relationship things. They can help a little bit with them. It's still in the early phase. I'm just getting started with researching it and learning it. It was just released at Roots Tech, so it's still relatively new. But that is something to help out when you want to see statistics of how do we relate. There's another tool called Watto, and that's been out for a while. That can be found on DNA Painter. That's if you don't have endogamy or any of those PEM stuff, okay? And that can help you clarify which family member does this belong to. You input a tree and it'll give you statistically your chances of being related to the person in different ways. So there's all kinds of tools out there. Watch multiple videos. YouTube has all kinds of videos. Family tree webinars, they're awesome. Roots Tech, we just had Roots Tech. Theirs are still up for viewing and stuff. Different ones, I learn different things from each one. Each one can tell me something that I hadn't remembered or that I totally forgot, or, oh, if I do this, that might help me make it a little easier. Okay, so now, any questions? Yes,
Do you need to have your DNA tested by Ancestry? Should I have it tested under different sources for different information, or is that Ancestry DNA test all I need to do research?
you can start with the DNA like on Ancestry. The thing is, the more you test, the more companies you test with, you're going to get different matches. You'll have overlapping matches, but you'll also have different matches.
Based on who's been tested by that. same-
Exactly. If somebody went to 23andMe and tested there and didn't test at Ancestry, if you do 23andMe, you can pick up those matches. And GEDmatch is a standalone company as well that you can combine a lot of these two, or you can set up your own. There's a lot of times tools for working with the matches and stuff when you've got lots of matches on that. But yeah, the more you test with different companies, it kind of falls in place. I've done living DNA, and I think they're just now starting to get some matches on there that I've done. Yes,
Is there a way to download my DNA test from Ancestry and put it on other websites?
it depends on the website. Ancestry, I don't think they want you to do that, but they're, yeah. And then if the company, some companies will charge you $10, maybe 20 by now to upload to that. I've done that. I've downloaded it and uploaded it to the companies that let you upload it. Sometimes they'll have a special where you can do it for free. Go for it.
That's less expensive than buying a regular.
Less expensive, yes. And there's always sales going on, which is wonderful because you can get others to test that way too. Because sometimes you may end up footing the bill if you target test, and they'll only do it if you want to pay for it. But yeah, the more places you have it, the more you can run into matches, and you never know when that one match is going to break that brick wall. Okay, any other questions? Yes, sir.
What is the genealogical proof standard?
That is the standard of requirements for the genealogy world.
Yes.
Genealogy kind of started out like it's a personal thing through family stuff, and now you've got professional genealogists and certified genealogists and all these others. And so they decided that there needs to be some consistency to give it more relevancy. You know, for lawyers, there's certain standards you have to meet. And the genealogical proof standard is basically reasonably exhaustive research. It is, you know, citing your sources. It's taking care of any inconsistencies. It's just an outline of things that you really want to do to have better quality research and have general standards among others. Okay,
Think of it as like a business best practice.
yeah, best practices on it. Good. Any other questions?
There are
Okay, hopefully it wasn't too bad. I noticed I skipped a slide in there. That button wasn't working for me too good. Yeah, if you want it, well, not, now, not the exact wording that I've, not the talking, but I can do the presentation. Linda C885@gmail.com. Linda C, as in cat, 885@gmail.com. And if you have any questions, just holler, because sometimes I don't remember exactly how I put it. Or I'll go home now and I'm gonna say, I forgot what I meant by that. I forgot to share that. But it's fun. And I learn better by talking about it sometimes too and applying it and, you know, pulling my hair out, even though this is all natural. It was gray before I started DNA, but it's definitely not going back to any other color now. But yeah, there's so much potential with it. And finding cousins and finding the relationships, finding the stories. But yeah, feel free to email and I'll send you the presentation. Anything else? Thank you all. Thank you.
I would check that.
Now you can all go back to your DAR research. Let's see. I'm almost done.
Okay, all right. Okay, I guess we are good here. Thank you all for coming. Seems like we're all finished. We should have, our next one will be the second Saturday of May. No, it doesn't look like it. So are you asking for Linda's email, I guess?
Linda C 885 at gmail.com. Didn't have to put my face up there.
No, sorry.
About that, Linda C as in cat. Here,
Say you might be able to.
Yes.
you didn't get that. Let me see if I can put it in the chat.
Oh, there we go.
Okay.
Hold on. Oh, there we go. It was just slow. Hopefully that's
Right, yeah.
okay.
Did he put something under there?
No, I think it was just,
Okay.
it's just
That's
one,
it.
leaving me another spot to reply. Okay, all right. Thank you all, and you all have a good day. Thank you.
Right, oh no.